Just kidding about that. We actually have a little bit more of 3.2 here. Are you ready for more? Here's triangle A. Reflect triangle A across the line x equals 2. So when we're talking about that line x is equal to 2, we're referring to a vertical line. Because if I'm just going to go the x-axis, find out where that is equal to 2, and everywhere on this line, I'm at that same coordinate, x equal to 2. My x value is not changing as I go up and down this line. So that's the line they're asking me to reflect over. So I'm going to label these points because it makes it a lot more clear in my diagram. I'm going to call this x, y, and z. So if I look at this, x is all in the line of reflection, so it's going to stay right there. So x prime is actually going to remain the same as x. Z, if I go straight to the line perpendicularly, I'll go 3 units to my left, so I'm going to go another 3 units over here. Well, technically, it's at 8 to 2, so it's actually 6 units, but 3 spaces. So then another 3 spaces, or 6 units, over here will get me to z prime. Y is 2 units away, or 4 units away, or 2 spaces. So I'm going to go another 2 spaces over, or 4 units, to get to y prime. And when I connect the dots, I should see a perfect mirror image of my, literally an image. That's the geometric term of A, so we'll call this A prime. And that looks pretty perfect to me. If I were looking in the mirror and I look like this triangle, that's what I would expect to see. All right, so write a single rule that reflects triangle A across the line x equals 2. Okay, this is pretty cool. I've never done this before. So what I would do if I was solving this problem is I would write my coordinates out so I could see exactly what they could be looking for in this rule. So x is at 2, 2, y is at 6, 8, and z is at 8, 4. All right, let's see how they relate to the image coordinates. X stays the same at 2, 2. Y prime becomes -2, 8. And z becomes, z prime becomes -4, 4. Whew, that is a tricky one. That is not so obvious. All right, well, one thing I noticed right away is that all my y coordinates are staying exactly the same. So if I'm going to say that I started x, y, I know that at least the y I can keep the same. There's nothing I need to worry about there. It's only the x coordinates that are going to change. So I'm going to focus on the x coordinates, and I'm going to create a table. I'm going to say original and image. So I go from 2 to 2, 6 to -2, 8 to -4. So first thing I'm going to do is I'm going to look at my rate of change. So I see +4, +2. And here I've got -4, -2. So that is a consistent rate of change. If I do my change in y over change in x here, I can get -4 over 4, or I can get -2 over 2, and that's just equal to -1. In both cases, I get a slope of -1. What I'm going to do next now is find the y-intercept, because this is clearly a linear function because I have a constant rate of change. So I'm going to write y equals -1x. I'm inputting -1 for my slope. This is just algebra review. No one would expect you to do this in the Regents, by the way. This is totally above and beyond the curriculum. And I don't know my y-intercept yet, so I'm going to put a b there. Now I'm going to plug these 2 points in to test out, see what that b is. So I'm going to plug 8 in for x and -4 in for y. Right, so I get -4 equals -8 plus b. Add 8 to both sides, and I get 4 is equal to b. So I can say that what happens to my x coordinate is I take it, I multiply it by -1, and then I add 4. All right, that's pretty interesting. I don't know if that line has any special meaning on the graph. Let's see if I plot that in purple just to experiment. I've got a y-intercept of positive 4, and I'm going down 1 over 1. Well, it does go through the it goes through the original point, which I guess is interesting. I mean, the point that's shared on the line of reflection. But I don't know. I don't know what other relationship that line has with the two triangles, why it ends up working out so well with this line x equals 2. Yeah, I'm not really sure how you could figure that out just by looking at the diagram. I think you sort of have to look at the coordinates and make a rule. If any of you are able to do it by looking at the diagram and finding some way, that is something I would definitely award extra credit for. That'd be very cool. All right, hope that didn't hurt your brain too much.